94C6. And if you want a specific place and time to meet, then we can meet at the next break in the room, which is just behind this room. So if you are interested in signing your keys, and even if you not participated in this procedure, you can come with your fingerprint, and we'll sign your key and bring your ID as well.
Okay, good morning. Welcome to day 2 of the Oarc 24 workshop in Buenos Aires. Sorry, I'm just trying to find the announcement slide. Okay, sorry about that. So, thank you everyone for your contributions yesterday. I think it went really quite well. I'd like to thank our sponsors again, premium sponsors ICANN, Nick.br and VeriSign, benefactor sponsor Comcast, patron sponsor NTT, and contributor sponsor Silicon Networks. Just a quick rerun of the announcements from yesterday. I'm sure you've all probably found the Wi-Fi. We've rebooted the access points this morning to hopefully avoid the recurrence of the issues yesterday. There is IPv6, but it's only available in a particular SSID, and we can't offer it the same performance as the main network. Coffee breaks are in the lobby area just outside. Lunch is upstairs in the patio restaurant where the social was last night. Toilets, if you need to go to the restrooms, exit the rear of the room or on the left. In the event there's a fire alarm, exit the room and turn right and go up the stairs to the assembly area outside. And you should find all the food clearly marked with any dietary requirements. Also, please remember your name badge for lunch today. Andre has just explained about the PGP signing. If you need help with anything, red lanyards are staff and program committee members, blue for board members, and please make all our first-timers with the yellow lanyards welcome. When you leave today, if you could return the lanyards and the badges, the badge holders, that would be appreciated. Webcasting, thanks to Dave's efforts here, on Google Hangouts, YouTube. There's a Jabber room, so please use that as a preferred channel if you're watching remotely and want to ask any questions. We didn't have any beeping device incidents yesterday, so hopefully we won't have any today. If you're asking any questions, please line up at the microphone stand. You'll be on the webcast, so please identify yourself and your affiliation before asking the question. We just did a little Medium blog post about yesterday's proceedings. You can find the real-time coverage on the Oarc24 hashtag. We've got all our speaker slides, so thank you. Unless you're in the panel this afternoon and you haven't uploaded your slides, then please do that ASAP. We were well ahead of schedule yesterday, so hopefully we can keep on time today as well. If anyone's up here speaking, try not to emit any RF into the audio system. And thank you to our speakers. The only other thing that I want to mention is that if you're interested in sponsoring Oarc 25 in Dallas in the autumn, if you commit today, then we can give you 10% discount on our usual sponsor packages. So with that, I will hand you over to Program Committee Member Anand Budev, who's a session chair for this morning.
Thanks, Keith. Good morning, everyone. Welcome to DNS Oarc 24, second day. Our first speaker this morning is André Souris from CZNIC, and he's going to talk about the Not DNS resolver.
Thank you, Anand. Just a question at the start. Who have seen my presentation at the ICANN 55 in Marrakesh? Not many hands. That's good. I also have some new content. My name is André Souris from CZNIC, and this is a presentation about our, well, not so new, but still fresh project, Not Resolver. So what is Not Resolver? It's not just a plain resolver. We think of it as a recursive DNS service and a platform to build more complex solutions than just, well, simple resolver. It's open source. We do everything under GPL. It has full DNSSEC support, including the negative trust anchors and automatic trust anchor management. It's version in C and Lua JITs, which is very fast. And it's built on top of not DNS library, so it doesn't replicate code for, I don't know, bucket parsing and stuff like that. It's using the already well-tested code. The daemon is scriptable because the configuration is in Lua, in fact, so you can write programs in the configuration. And it is a very simple core, which is extensible with modules that might be written in C, Lua, and Go. And, well, we are looking for some other languages to have support for. We do some nice things for IPv6, like Happy Eyeballs. And it has no internal threading. It's just, single program, but it scales by self-replication. And with the new Linux kernel options, SRU port, you can just run more daemons at the same port, and it scales very, very nicely. Who is it? Basically everybody. Well, we focus on all features, and you can find anything for you, even if you are a large recursive DNS farm, and even if you are just personal resolver running on your laptop. Also, well, the geek thinkers and people who plays with the code would be very happy with what we did, I think. So why for large recursive DNS farms? It really scales. The really fast scriptable engine can change resolution on the fly, and so if you have some needs, how to, I don't know, block some malicious content, you can do that very fast. It has flexible shared cache backends. The default is LMDB, which is probably the fastest open source key value database at the market right now. And it's shared between the daemons. So if you run one more, then it will just connect to the shared cache and use it, taking benefit of the pre-filled cache by the other daemons. And it can also use network cache backends like Memcached or Redis. So if you have a big farm running on multiple servers, then you will just need a shared instance for Memcached or Redis, and it will use it for all the nodes in the location. So it has great statistics. It can plot with Graphite backend, and you can import that into those things like InfluxDB and draw graphs with Grafana. It has support for negative trust anchors. It's cluster aware, so you can use etcd for core OS, from core OS for shared self-configuration. It has views and ACLS support and, well, prefetching to keep the cache hot. So for small recursors in private networks, which is another, well, deployment, which might be your university, campus network, company network. It has QNAME minimization for DNS privacy. We already spoke that yesterday. It has very good DNSSEC and RFC 5011 key management. So you just fire up the daemon without any key, and it will download the key automatically from IANA, check the checksums and the PKI that it matches, and it will use the key automatically. It has very low memory consumption, and the cache can be paged out, and, well, the default LMDB is mapped, so it will be handled by the kernel automatically. It has a query policy-based resolution, so you can match the queries based on pattern, suffix, response policy zone, and do some action over it, like, well, deny, drop it, forward it somewhere, switch to TCP. And it has DNS 64 support to complement NAT 64 if you are really hip and you are running only IPv6 only network. For personal resolvers, I already mentioned you don't have to, well, download the trust anchor for the root. It will just do it automatically, so you just give it a writable file for that. And that's basically the only configuration you need at the start. It has persistent caching, so the cache survives restart and even a reboot of your machine. It has really nice, well, simple monitoring. I hope it's running still on the URL. I didn't check in the morning. So it's very soothing to look how your queries are resolved. And then we plan also to do more stuff on DNS privacy, like DNS over TLS and better handling of those almost Wi-Fis at the hotels that will just do everything to make you mad. So for geek thinkers and people who love to play with the code, the daemon is scriptable without binding to port 53. And there are some Lua scripts that take advantage of that. There's also full API specification in the documentation. So there's, as a demo, there's KRSD host utility that's host-like, but host-like utility, but it's just a simple script that runs the daemon, passes some comments in Lua, and gives you back the results. And then there's more advanced KRSD query tool that you can just call the functions from the API using that. So there are some examples how to, I don't know, print the queue name from the answer, how to print the R code, and well, you need to read the API specification to take a full advantage of that. But I think it's very nice that you can just run the more complex scripts without running daemon. So current status, we are planning releasing the versions 1.0.0 next week if everything goes well. We want to merge some small fixes that are in the development, and then we will release what we might call the first production version. Anyway, I'm running it on my personal laptop for half a year, and I found some bugs, and we fixed that. So I ask you to try that as well. It has a very nice documentation that there's URL there, and you can give it a try. So if you run that and you find it works well, we would like to hear that. If you find it doesn't work well, we would like to hear it as well. So please do. And now I have some examples. What can be done via the API and via the modules. We have a policy module, and this is an example of the filtering. So the first bullet is you just load the module in the configuration, and then for example, the next bullet is that you whitelist www some numbers phishing domain. So you add a policy to pass those, and then you add the next policy that will just deny all other traffic that has a suffix end with .phishing. As you can see, the patterns are written in the wire format, so it's always the numbers of characters in the label, and then the label. Or you can use add a custom rule written in Lua, so more complex rules can be written. Or, for example, you can add a function to deny all any queries. That's the last bullet. The same policy module can be used for forwarding. So you just here we use the pass deny rules and drop. You can switch that to forward, so you can For example, for some specific domain name, you can forward the query somewhere else, or you can, well, in the last bullet, you can forward all of them somewhere else. Then the policies and views can be used to define views and ACLs. It could be based on TSIG. The first example, you can, well, block local queries with the ACLs. You can drop some queries based on the IP address of source IP address of the queries. You can use RPZ in that as well. Or you can, well, again, you can use the forward policy to forward the queries to some other resolver just for some clients. All that could be scripted and changed on the runtime as well. Here are the examples of the network cache. So this is memcached. You just load the module for memcached and switch the cache storage for either for the local socket. You can use multiple memcached servers. And you can even combine the socket and the network servers in the configuration as well. For the Redis, it's similar. You just define the load the module and define the cache storage to be located in the Redis. And that's it. That's the only configuration you need to have a shared cache between multiple instances, network instances. Here are some more examples what can be done with the node resolver. This is the DNS64. Again, very simple configuration. You just give it the prefix and the IPv6 prefix that will mangle the IPv4 responses. The next one is the graphite backend, which is protocol for statistics. So again, you just configure the prefix for the metrics and where to send the queries, where to send the statistics. You need to have a listener there. And the last one is the tiny web I told you about. This is the Grafana, which is the external tool that you can feed the graphite statistics in, so you can draw some very nice graph. And this is the tiny web output. So the green one is cached, and then the more lighter color, then the more time it took to resolve that, and then there's a geo IP map of the distribution of the name servers. As I said, it's very nice to look at when you have nothing else to do. And so I'm finished with the examples. So you are welcome to tie a knot.
Thank you, Andre. That was very enlightening. Any queries for Andre?
Policy add, drop.
Ralph, not a query, but a question. The happy eyeballs, you said, is that on the inbound request, meaning you give it back to the client, or is it on the outbound for the recursing?
It's for the, I just forget. Well, there's a database with the times for that it took time to resolve when you use some, it's for the outbound, basically, and for the reputation database of the name servers.
So you pretty much send the query over V6 before you send it over V4?
Yes, yes.
Okay.
And then it will sort itself if it's faster or not.
But if the query is cached, then it will be sort of, whatever comes first will be first.
Yes.
First. Okay.
No? Okay. Thanks.
Okay, thank you.
So our next speaker is Francisco Cifuentes. Bienvenido, Francisco. And he's going to talk about threshold cryptography distributed HSM.
Hello, my name is Francisco Cifuentes. I'm going to talk about a system that we have been developing during recent years. It's called Threshold Cryptography HSM, or TCHSM. We presented this at Oarc 20, and now I'm going to give an update of this. Okay, so what's threshold cryptography? Okay, let's think about regular RSA signatures. In regular RSA signatures, we have a public key and a private key, and we use the private key to sign documents generating a signature, and we use the public key to verify those signatures. In threshold cryptography signatures, or threshold RSA signatures, we have a public key and several key shares. And we use those key shares in order to generate partial signed documents, or partial signatures. Then we have to join these partial signatures, and we generate a regular RSA signature that is verifiable with a regular RSA verifying function. So why is this threshold? Because there is a certain number of valid partial signatures that are needed to join and generating one regular RSA signature. For example, 3 out of 5 as seen on the slide. Okay. HSMs, or hardware security modules, are specialized hardware used to do cryptographic operations in a secure way. In order to communicate with them, it was developed a standard API called PKCS11, and that is the API that you have to use, that the application has to use in order to use the operations that the HSMs provide. In our system, we developed a PKCS11 API implementation in order to call a distributed system. This distributed system implements a threshold cryptography protocol, and we claim that using threshold cryptography, you can have a security level similar to some secure HSMs. But in the design that we show at Oarc 20, there was that central node called master node that was a single point of failure. Having a single this is a problem because we wanted to have a fault-tolerant system. So we sat down and rethought the design, and we redistributed the things that were done by the master node into the worker nodes and the PKCS11 implementation, with the trade-off that now the API has more complex logic inside. This design update gives us the flexibility to use the nodes between several applications, even if they don't share all of the nodes, like shown in the slide. Okay. So what we actually did, we rewrote the threshold cryptography algorithms library. We wrote a threshold cryptography distributed system that uses that library, and we updated the PKCS11 API implementation in order that uses that distributed system and make it possible to use it with any HSM compatible software, such as OpenDNSSEC or the Node Automatic Signer that has in the authoritative DNS server. So let's look at how's the system operation. First, I'm going to talk about how to generate a key in this system. In order to generate a key in this system, the application calls the API with the generate keys function. Then the API generates the key chairs and then send them to the nodes in through a secure channel. And then the nodes store the keys in a secure way. So how the system works in the signing operation? First, the application has to call the signing function in the API with a document. Then the API broadcasts the document to all the nodes. Then the nodes do their partial signing operation and gives back the result to the PKCS11 API. And notice that we don't need all the answer. We just need a certain number, the threshold number, for example, 3 out of 5 here. And then the PKCS11 API, again, joins the partial signatures and generates a regular RSA signature and gives that back to the application. Notice that the application doesn't even know that it runs through a distributed system. These are some systems performance numbers. We ran this test with a master computer that ran the test application with the API implementation, and with a test machine with 3 Docker instances that ran each instance ran a node of the system, and we simulated latency between the machines. The simulated latency was of 5 to 70 milliseconds. And with this setup, we generated an average of 80 RSA signatures per second with a 1024-bit key. And we generated 1 RSA 1024-bit key on average 6 seconds. Notice that these numbers were obtained. We get these numbers by calling the PKCS11 signing function in a serial way, doing serially. We might get better numbers if we call a batch, the distributed system API directly, with a batch of documents to be signed. This wasn't done in this test because the API has some constraints on doing this. The PKCS11 API, not ours. Okay, so for future work, we have the fully distributed key generation. That means that the node itself generates a key instead of the API generated them. Also, we have we want to test this system with more applications, possibly in other fields beyond DNSSEC. Okay, so that's it. Okay, any question?
Thank you, Francisco. Questions?
Hi, I'm Jan, CZNIC. Nice presentation, thank you. I'm especially glad that you mentioned that no DNS can use it. My question is about the security of the device. So this is purely software implementation, right?
What?
The token or the distributed system is purely software implementation.
Yes.
And the key material is protected only by the scheme which is using this partial signatures, right?
Yes.
Okay, thank you.
Paul Hoffman from ICANN. So a couple questions. Which RSA are you using? Are you using the identity-based system that like Dan Bonnet did, or are you using the original, you know, the one from Shafi Goldwasser when they first described threshold-based? Are you using IBE in it or not?
IB what?
IBE. I'll take that as a no. There was a later addition to threshold-based encryption.
Okay. We are using the practical threshold signatures from Victor Shoup. I don't know if.
Okay, from the original. Okay, good. Just because IBE has a lot of patent stuff on it, it's a little bit faster. But I wanted to make sure you weren't doing that. And then my other question, which is sort of a bigger picture, is where do you see this being useful in DNSSEC if all of the individual nodes that would be doing, you know, creating their own partial signatures sort of have the same security posture as a central system? Why would somebody go to the much slower threshold given that you're getting pretty much the same security?
I think the main trade-off that we are trying to get advantage of this is the price. The HSMs are expensive here. Okay. What?
Hi, can I speak briefly to that?
Yes.
We in APNIC have an HSM burden both for our PKI functions and for our DNSSEC signing and for internal and customer-facing certification needs. And we made a decision to invest in a commercial HSM. And it's like signing your life in blood to the devil because you buy into an ecology of hardware that is incredibly vendor specific. And these people are essentially selling less than 10 units a year, and they have to maintain supply chain for you to guarantee that your keys are not lost because of failure. It's an incredibly expensive and complicated sell, but it's also, to quote Admiral Akbar from Star Wars, it's a trap. Because there's a generational transition problem that you must maintain lockstep with their hardware functions. The vendor says we will not provide key transition across more than one generational shift. So for me, you're right, there's money, but it's also HSMs are a trap. This mechanism has potential to mean you are not captive behind a key store architecture where the vendor can walk away from you. And I find that much more interesting and attractive.
But stay here because using the threshold-based system where you have individual people making parts of keys is no different than having just a software-based HSM. That is, from a security standpoint, the whole idea of threshold-based cryptography is that everyone making a part of the private key is just as secure as a central person making the whole thing. So if you want to get rid of hardware HSMs, which I think many, many people would want to do, this doesn't offer a security advantage over just buying a Linux box and using that as an HSM.
Except
so
it doesn't have a single point of failure. It's distributed.
No, it does have a single point of failure, even with the PKCS11 module, which is if you're using the same security on each one, and your concern's not just, oh, this box isn't available, but in fact, if your concern is someone was able to look at how I generated the secret keys. I'm hoping that I'm saying this correctly.
Yes.
But that the security would then be just, the problem would be distributed across all of them. So I'm just wondering, is there something in the way that you're doing this that actually makes it more attractive from a security standpoint than just having a single box being a non-hardware HSM?
No, I was thinking that maybe we can think about this by using for example, some lower level HSMs in the nodes.
Yep.
So we can store them with better security, but we gain a security level by distributing them geographically, for example.
Okay.
So
Right. I would say gain resiliency more than security.
yes,
Yeah.
I think.
Okay, great, thanks.
Okay.
Any more questions for Francisco? Okay, thank you, Francisco. That was a very interesting presentation. So coming up next, we have our next speaker is Casey Desio from VeriSign, and he's going to talk about DNS measurements from multiple vantage points. Welcome, Casey. Sorry? That's kind of tricky because it's also. If you can use your uploaded presentation, that might be easier because this is all connected.
Okay. Well, I've got a demo I was going to try and use, but
Because Dave's also doing the webcast and it's just moved off.
so you can ask him. Where's our text?
Is that yours? Yes. Oh no, that's not the one. This is yours. There's the PDF and the keynote.
Oh, it's a keynote. Shoot.
But you can use both PDF and keynote.
Okay. All right. So I just won't do the demo, I guess.
We have time, so we might be able to once Dave's back.
Okay. But we just have to wait for Dave.
Yeah, I don't know where he's gone off to. Just once. Sorry, folks. Just give us a minute here, please. We're trying to sort something technical out.
Okay. I was going to try and do a demo, but we're waiting for our technical expertise. No, okay. Fair enough. And I'll just...
You can use either the PDF or the keynote.
All right. Well, I haven't practiced with the keynote, so I'll do this one.
Okay.
All right. Glad to be here. And today I'm going to talk about multi-vantage point. Excuse me. I'm fighting a cold here, so I'll do my best as I'm speaking to not distract from the presentation material. And my name is Casey Desio, and I'm from VeriSign Labs. So first of all, you should all be familiar with the key parts of DNS name resolution, the three main components that we typically talk about: the stub resolver, the recursive resolver, and the authoritative servers. And this is the chain that we oftentimes think about. Okay, and obviously there are variations to this. The key part that I am focusing on today is the middle part, which is often unknown, between the stub or even the application and the authoritative servers, where you're ultimately getting your information from. And there's lots that can happen in this question mark, this area in between. Of course, you could have recursive resolvers, as I showed previously, but it might not just be one. You might have a chain of several. They might be known, or they might be intercepting and redirecting. Okay, you have other types of middle boxes that might be there at the application level or network level. Firewalls, NATs. Of course, we're talking multiple network level protocols, IPv4, IPv6, and the paths associated with that, including anycast nodes, which might lead you to different places depending on where you are. And then, of course, you have a number of authoritative servers that you might be hitting, and the authoritative servers might, thank you, appreciate that. The authoritative servers may actually give you different responses. They may be they may not be compliant, some of them, and so forth. So those are some of the things you might see in the path in between, of course. And then some of the things you might be looking to diagnose along the way that might be of interest because of these things: TCP or UDP connectivity, response latency. If you're doing measurement type exercises, you might be looking at EDNS capabilities of the end server or of the path, and whether that entails EDNS version, options, flags, etc. And certainly with more and more capabilities coming online that use EDNS, some of which we've already heard about, that is important to look at. DNSSEC records, whether or not they're being dropped, large or fragmented packets, different record types that might be refused for various reasons, and then response correctness and consistency across the servers. So the utility here now in looking at these, if we try and boil these down, is we want to measure and monitor authoritative or recursive DNS services from these different vantage points. And of course, this is to provide good service, whoever we are and whatever service we're providing in these different areas. And of course, to understand client perspectives and problems. And then we want to be able to diagnose these problems from specific network locations. It doesn't really do us much good if things look good from one perspective, not from another. And I'm sorry I don't have it here, but there was a great recent post from DNS Reactions that was fun, that basically had somebody saying, hey, everything looks good from DNSViz, but from this resolver, it's not good. So what is going on? And that's the question we ask ourselves sometimes. If one tool or one location says it looks good and someplace else says things aren't, then how do we figure out what's going on? And then of course, some of the work that I've been involved in the past has done a lot of work looking at authoritative servers and what the responses look like there. But really where the rubber hits the road is at your own cache in your own network and what is there. Because ultimately it's the one that's giving you the response. And that could be at your local client, or it could be in your enterprise, or wherever that may be. Okay, so I'm going to talk a little bit about, DNSViz. Some of you may be familiar with it as a web tool. There's also a command line version suite that is available, and I'm going to go through some of this to talk about Vantage Points, and then talk about some new features that are both available in DNSViz as well as for the general measurement community. Okay, so traditionally the way it's worked with DNSViz and is available in the command line suite is that you use this DNSViz probe to go out and look to talk to the authoritative servers, and it issues a set of diagnostic DNS queries to these authoritative servers, and it will excuse me. It will begin at the root if you specify, but it'll follow delegations downward and diagnose problems, etc., and store all these raw responses. Something that's fairly new is the ability to also query recursive servers, and you can specify those on the command line using, like is showed here, the -S option to specify servers, that's v4, v6, whatever, and then allow those to find whichever authoritative servers they will. And of course, you can't predict that, where they're going to go, but you can at least see what's there already in cache, or what they ultimately retrieve from the authoritative servers. So again, that's using DNS probe without the -A switch, and optionally with the -S switch. Excuse me, switch. Okay, so some of this is available now in the web interface. If you're using this, there's kind of a, when you go to analyze a name in the web interface, there's an advanced options field where you can specify authoritative or recursive, and of course you have to specify recursive servers. And if you're doing this, they'll also have to be publicly available if you're doing this, because the server has to be able to access them. So here's some examples from this. This might be familiar for some of you that have used it, where if you're going and looking at a particular name from the authoritative view, you get kind of this visual representation of a chain of trust as has been processed by the DNSFizz tool, given the responses it was given when it sent these diagnostic queries out. And it looks perhaps somewhat intuitive there with a chain of trust, and everything looks green and good. And you can see among the items that are here is a request for example.com of type CNAME. The idea that was there to get a node data response, so that was on purpose. And I'll show you why in just a moment. Okay, so this is an authoritative view. If we use you'll notice there's no difference between these two right here. That's because if you're using a good recursive resolver, you should get the same types of responses and ultimate output. However, there are some other recursive resolvers, public recursive resolvers that we tried and actually got a different response. And these are non-validating resolvers, obviously, but in addition, they were not returning DNSSEC records. So this was an example of if you were trying to troubleshoot from your local host, why you couldn't do validation on the local host. This might be a very obvious representation of what was going on. You see all the records here, but you see no arrows between them. And the arrows, of course, represent the signatures that should accompany the responses that you are getting. So those are some of the DNS resolvers that are out here. Here's a more subtle one, however. In doing some testing in a lab type environment, we discovered another problem. And in this case, we were getting DNSSEC records, but we were not getting RRSIG records that covered the NSEC or NSEC3 records. And this may not seem like a big deal. Okay, those names don't exist anyway, not a big deal. The problem with this is that when you, without authenticative denial of existence, you are also unable to prove the non-existence of DS records. And for those of you that are familiar with DNSSEC, that is quite important for understanding that not all domains are signed, but you need some sort of assertion and proof that there is a secure termination of the chain of trust. So in fact, in this particular environment, you are unable, there was an inability to get a response for anything that was unsigned or otherwise below a secure chain termination or a proof of non-existence of a DS record. So this was testing on, this particular instance was Windows 2012, Windows Server 2012 R12 that we discovered this. And as I mentioned, all unsigned domains became unavailable. And this is, of course, because of the lack of RRSIG accompanying the NSEC or NSEC3 records. But in further testing, just to explain a little bit more about what we found with this, the problem only occurred when the server was configured to forward queries. And not only that, when we narrowed it down further, it turned out the problem only occurred when the, thank you. No worries. The problem only occurred when the upstream forwarder was bind. When we tried other implementations, it seemed to work okay. So if we take a closer look at the bind responses when you do a negative, so this is a bind resolver recursive service, and when you get the responses for a negative response, you'll note that everything looks largely similar in terms of the records that are contained. Everything seems to be there in terms of the proof. Just one slight difference that it took us a while to track down, and that is that the ordering was different. And this is compliant as far as the spec. But you'll note that the RRSIG is before the NSEC record, and that was tripping up the Windows Server 2012 DNS server in terms of validation. It just couldn't process that. And so thus the problem that we were seeing in this particular instance. So after a somewhat lengthy process, we actually did submit a bug report. This was my first experience doing this in this world. But they came back, and here was the knowledge base article that for which a fix was applied just a couple weeks ago. So anyway, kind of interesting, but this was meant to illustrate the point that sometimes you see things at certain vantage points that you can't see in other places. In this case, it was behind a recursive resolver where we really needed some things to help narrow it down, and the analysis, the targeted analysis toward the resolver helped us to do that. And this could be the case whether it's a bug, whether it's you're seeing cache poisoning or other types of misconfigurations or incompatibilities on the recursive resolver. That's the intent of it. All right, so I've talked about different vantage points using from where you are, but you don't always have capabilities to reach out from a different place, a third party, if you will. There are platforms out there that do it. You can think of Ripe Atlas as one great example of that. And there are different, with the different platforms that are out there, you can think of the different types of access that you have while you're doing these types of measurement or monitoring tests. So whether it's you have full shell access or versus some type of API, the queries might be canned, or they might be flexible enough that you can customize them. Looking at the different probes that you have access to, the locations, whether it's a different number or the location themselves that you're interested in. Synchronous versus asynchronous execution. Are you going to get a response right away that you can wait on? Is it okay if it's delayed and comes back with some type of callback? Okay. And a related theme is something that I term here sequential progressive diagnostics. And something that DNSViz does, for example, is it will do the next test is contingent upon the results of the previous test. Think if you're trying to diagnose whether something is a PMTU related issue versus a simple something is timing out because the server is down, then you're going to retry with certain types of characteristics, reducing the UDP max payload in the EDNS options or something like that. So at least for my case, it's useful to have that option where what the response is real time so that you can then change and do the next thing. In other words, you don't want to give full control to the third party to execute everything, but you do want to know the result as you're doing it. So there's interaction is valuable there. There have been discussions of DNS looking glasses in the past. This is kind of a new take on that, specific for diagnostics, but could be applied elsewhere. And I've identified here some of the useful request components. Certainly the message itself, or if you wanted to just take parameters that you would then compile into a raw DNS message, you could do that. The destination IP and port, of course, and optionally the source IP and port if that is helpful with your diagnostics, as sometimes it is in my own. Think multi-homed server or something like that. Transport protocol, of course, and then how long you want to specify for timeout before you stop waiting. And then the response components, of course, you want the actual message itself, but along with that, you'd want some type of meta information. If there is an error, a timeout or network error, for example, a little bit more description on that error, what that means, think error and the types of codes that are associated with that. The source IP and port, which were ultimately used to issue the query from this remote location, the time elapsed, which is useful, and then optionally a trace route, if you're doing further network diagnostics to see what was going on. Okay, some additional things that might be considered, restriction, security-wise, you don't necessarily want this, since this is a third party, they don't necessarily want you querying anything, for example, on their local network where you might learn about their networks. think resource usage. You may not want to have, may want to put a limit on simultaneous queries. You may want authentication. Okay, there are a few other items here. There's also the idea of ease of deployment. How easy is it to put up one of these? Is it somewhat straightforward? And I'll show you some examples of that in just a moment. Accessibility, how many people can use this. And then I already mentioned synchronous execution, parallel execution for optimal performance. Okay, so what I have come up with is a DNS looking glass over HTTP, where the client encapsulates the requests using JSON, and all the information that I mentioned in the 2 slides ago is included in there. The requests are sent to the HTTP server as encoded HTTP post, and then the server, if possible, will issue these requests in parallel as much as it can, or up to whatever specified limit there is. And the responses are returned from the HTTP server as the content. So in other words, you're sending one or more requests in a single HTTP request, and then as soon as all of them finish, then the HTTP server returns the response. So with the latest version of DNSFizz, there is a proof of concept looking glass implementation. The server side is implemented as a CGI script. Certainly this could be done in different ways, but using CGI the idea was to get it up and running somewhat quickly, at least for proof of concept, and so it's in the contrib directory there. And then there's a client, which I call DigViz, so only because it uses the behavior of, mimics the behavior of Dig, but has a couple extra options, one of which is plus LG for looking glass, and you specify some type of URL there, that you can then actually direct your query through that URL, and the HTTP server will be your looking glass to issue the actual query. So then whatever options you put, it builds this custom DNS request and sends it through this looking glass URL ultimately to where you are going. In this case, 192.0.2.1. Okay. This can also be used with the DNSFizz command line tools by using the -u option. So if you want to go through some type of a looking glass, you can just specify that on the command line. And again, it will do all the same things it would have in terms of IPv4, IPv6, following delegations, etc. But it'll do all of it through this third-party looking glass. Same thing with recursive servers. You just add the option, and you don't specify the -A, and it will do all this through a looking glass again. So in other words, you have several different dimensions for looking at this: recursive, authoritative, looking glass, no looking glass, and any combination of these. There is some implementation of this in the web interface as well. This is still a work in progress, in part because I'm learning the best way to do this. But right now there's an option for third-party location if you look at the DNSFizz form, and right now there's just a test place where you can do this from. A test looking glass in the form that you can select from the form. So if you go to dnsfizz.net, you select a domain to analyze, and then there's kind of an advanced options place, and you'll see under there, I was going to do a demo here, but anyway, there is one place you can test out there. Looking for other interested parties, if you're willing to host one from your own vantage point or from several vantage points, we're glad to add those in there. You can use the included CGI script, or you can implement the same API however you'd like. Let's see. And then the second one, okay, so this is the client-side looking glass, which is a different way of doing things, and that is, okay, the other one was the server using a third-party HTTP server, and this is a client-side looking glass in which you actually, if you select this option, your browser would start a Java applet. Okay, no one yell at me here, and that would be changing to what's the new thing, the Java Web Start, sometime in the future. But at this point, the idea behind that is to allow your browser to query something in your environment that you wouldn't normally be able to do with a third-party looking glass or with the DNSViz server as it currently stands. So if you want to see what things look like from your own server, you're either going to install the software that's available, or you're going to do this, run the Java applet, which will query your own server. Now, there are some issues with the way it's currently deployed. I'm having some trouble, namely with the getting the code signing cert to work properly with the chain. And so you have to, if you're going to try this out, which you're welcome to, then you need to specify DNSViz.net as one of your trusted sites, just FYI. I'm still trying to figure out how to do that, how to make it work without that, get the chain properly installed. And I welcome any help in that area if any of you have experience there. But anyway, I hope this enables additional perspective, particularly from your own environment, if you're not in a place where you can, download and install the software, and you still want to see the analysis or diagnostic results from your own DNS recursive resolver. Okay, so in summary here, we know that DNS name resolution paths can be diverse, and that getting perspective from different locations is good to help both an understanding of your services as well as to diagnose specific problems. DNSViz allows some of this both in the command line tool as well as in the web server, the web-based diagnostic tool. And there's also some looking glass software there that you're welcome to play with. Here are some links, the link to the DNSViz code itself, as well as the web-based DNSViz version. So any questions?
Well, looking glass are used extensively in the BGP world, and most of them have no API, and even when they have, it's different each time. So it makes them a pain to use them. For the DNS looking glass, what is your opinion about the idea of a standard for this? Because there have been several attempts already to standardize things like JSON over HTTP, DNS over JSON over HTTP, something like that. There is a draft currently live in the Dns Oarc working group, not adopted by the group. Do you think it would be a good idea? What is your stand on this?
Yeah, in terms of standardization, so a couple comments on that. One is that I think it would be useful so there can be different parties using the same type of communication. I mean, that's the whole point of interoperability, right? Different people can create tools that interoperate on a standards basis. That being said, a lot of what I have done here is diagnostic space. In other words, you're not simply getting a response. You have a lot more meta information associated with it. Some of it is optional. I need to go back and read the current draft that's on the table, but I know there's not as much meta information as what I've included here. It's possible that that could be included in optional, that a lot of what I'm looking for could be made optional so that it could work with something that's already on the table, though I would need to take another look to see where it's at. In general, I'm in favor of that because I think interoperability is great.
Okay. Understand.
But do take a look, it's not... Sorry, just to follow up real quick. Do take a look at this, both in the slides and, the concepts are probably more important than the actual implementation here at what's included. I am interested in feedback in general, and I'm happy to, if people think, boy, you should kind of write this up so it's a little better documented, I'm happy to do that.
Ralph Weber, Num. Thanks a lot, as always, for all the good work you do for DNS measurement and diagnostics. I really liked it. I didn't know about the resolver option, DNSViz, so that's bad on me. You said, of course, it only works for public resolver. Would you be willing to share the vantage points with people who are using closed resolvers just to participate?
Can you elaborate? What do you mean on that?
Well, I mean, the resolver part only works if the resolver allows you query.
That's correct.
Which public resolvers do, but kind of non-public resolvers don't. So you obviously, with DNS Viz, the website, have a list of vantage points you are using. Would you be willing to share this with people so that they can actually open it up for you?
Oh, yeah, you mean in terms of, oh, I see what you're saying. So that you could say, access list, allow DNS Viz to come in and do this too. Oh, certainly, yeah. And in fact, if any of you are running resolver services and you want to allow that, great. I could make arrangements for not only IP address, but TSIG or whatever makes sense to do to secure it. But yeah, that's a great.
Great, thanks a follow-up.
Happy to do that. So thanks, Ralph.
Paul Hoffman. So I was sort of going to ask a similar thing with the, well, how would we know where you're coming from? But you just said maybe T6, so that's great. Going back to either one or two slides before where you were talking about the client side.
Oh, yes.
That one, yes. And your joke about Java and how horrible it is, which I agree. I understand that you would need Java or Flash to be fully capable, but you could do basic things in just a JavaScript. That is, if you were just sending out a simple, I want an A record or a quad A record query, you could do that from JavaScript that could work anywhere. Have you considered that as a way of at least bootstrapping for those of us who either can't or won't do Java in the browser, but still to do, because it would be wonderful to be able to say to somebody, here, go here and tell me what you're seeing, at least on these lines. And I think most of the things where we fall over are on A and quad A queries. So would that suffice for you?
The short answer is no.
Okay.
Well, and, I mean, if you think about what's available in terms of the JavaScript sandbox, I have to go outside the sandbox to do what I'm doing here,
yes.
In part. And so I'm not just talking about the flexibility that Java gives you. Java, sorry, I don't mean to be touting Java here, but
nor do I.
But in terms of what might be available on a client-side system, right? So anyway. So I have to go outside the sandbox for that, but also, I mean, if you think of what the API is like within JavaScript, it's similar to like a get host by name type, but I really need more than that.
What more do you need? That's what I'm asking. For JavaScript, what more do you need other than I don't want to just ask for A's and quad A's?
Well, part of it is to actually look at which server you're going to. I mean, if you think of the most basic levels, but if you go back to what kind of things we're looking at here. So specifying the destination IP and port is part of it for the request. Also the transport protocol, if you're looking at that. But also some of the meta information that you'd be getting back, in particular the error type that you're getting, whether it's NX domain, whether it's serve fail, what type of responses you're getting. Maybe it's a network error. Maybe it's are you getting a PMTU type error that it's detected. How can you change that, and how can you do things like EDNS options, for example? So the idea is to be able to form a completely custom DNS message, which you can't do with get host by name. There you're just sending whatever the underlying stub resolver library is going to do for you.
Okay, so you weren't thinking of essentially setting up a little local looking glass, which you could then do that from JavaScript. You're saying you just want the web browser out there to be able to be a thing that will launch something for you.
Yes.
Yeah, okay.
So I want it to be.
You are stuck with a Java or a Flash.
So think of it as a diagnostic looking glass. I'm not as much interested in just the response or the lack thereof. I want to diagnose what's actually going on. And so looking glasses, the way that they've been designed, at least in this presentation here, is they're dumb enough that they're just going to do what you've told them to do. In other words, they're not trying anymore. They're not going to do more than one query. They're going to try whatever you gave them and come back, and they're going to wait for the next. They'll just wait for you to tell them what to do next. So even as much as timeouts, if you get a timeout, it sends back, oh, we timed out, and you have to tell it whether or not you're going to do it. So all the policy is back at the client that's driving this. If you look at the client side, in the web-based thing with the Java-based client, it's a looking glass in the sense that it's starting this up and communicating with the server, and the server's telling it what to do next in that case. So So that's the idea. So flexibility enough to do all these custom things, but it's still dumb in the sense that it's being told what to do.
Right, and so that's what I was wondering, is if you could push that dumbness down, like if by using JavaScript you could get a start, and it sounds like that would be almost too little for you.
Yes.
Yeah, okay.
Now there are some there is some related work. The ICSI folks who excuse me, created Netalyzer also created a it was a Firefox plugin, and I'm trying to think of the name. It was Fathom. Does anyone know off the top of your heads? I think it was either Fathom or Phantom. I can't remember which. I'm sorry, I don't have the right reference. But the idea was with the plugin, they were able to get within JavaScript the functionality that they normally had to do within a Java applet. And it was quite nice, but of course it only worked for, I think it was Firefox, but they may have been working on other ports. And of course you had to install the plugin itself. So I'm not sure what the status of that is, but I remember that was an interesting topic. I chose to go, at least for this purpose, the route of Java for whatever reason. So that's where we're
Thanks,
at.
because I actually would look, I didn't know that anyone had walked that down that far, and the ICSIA folks are pretty good on that, so I'll take a look at that.
Yeah.
Great, thanks.
Oh, okay. Well, is anyone interested in seeing a demo, or are you anxious to move along?
Raise your
Okay.
hands if you want to see a demo.
Okay. Wow.
Okay. Okay.
Fair enough. Can I use that plug?
Yes.
So here we have our live demo, and by the way, now there is a link to the GitHub repo. But if we go, so this is looking at dnsviz.net, and if I go down to Analyze, I'm going to try a couple different things here. So you can see, I'll just show you under the, and this is under Advanced Options, in part because some of this is still proof of concept, and I'd like people that don't know what they're doing to not get tangled in it. I'll get some interesting, I'll still see some interesting things in my logs from people trying to do things that it really wasn't intended to do. Okay, so these are your kind of your defaults, if you will. So perspective, you see DNSViz server is the one doing it, and that's what you're used to seeing, and you're used to seeing authoritative servers. But if I change this to recursive servers, and just to follow that DNS reactions, and because it's right there, I'm going to do recursive servers, and I'm going to change this to web client. And yes, I'm going to allow that. I'm going to allow and remember, and we should see some. Now again, I have had to go into my system preferences and allow dnsviz.net in my. Okay, so I'm going to allow that to run. Don't worry, this only takes about 10 minutes, so. It's Java. It's Java, that's right. It's loading the entire Java virtual machine. And thank you, Jared. Appreciate that. I'll just show you real quick what. where this, in case you're not aware, in the Java preferences, for those who, does anyone even run Java in here? You don't have to raise your hand, it's okay. Yeah, so this is where you would have to add that in for now until I get the cert working. It's a very painful process. It is in fact Java, yes. So apparently I can't access 8.8.8.8 from here. Maybe I need to have someone from Google allow me in or something. So this is Such It Is with live demos here. Let's try one other thing while this is running. Yes, I can do that. I will need someone to remind me of the addresses. Sorry. Or maybe DNSViz.net is simply inaccessible and it's taking forever. I should know this, but I don't. Let me try one other thing here. What's that? Are they open? Yeah. I can try that. Let me do one other thing while I'm here. So I'm going to try this third-party looking glass. So here's where I've put the looking glass, and I just have a test one there with third-party other. And so with here, I can actually do authoritative servers because the idea is to get, you can get either perspective from here. So I have third-party other here, looking glass, test looking glass, and I'm doing an authoritative analysis. And I'm going to change this right there. Okay. It's still going, good. So hopefully this should work. This was working when I was sitting down. I was very confident in my live demo. Okay, so this one worked. Going through the third-party looking glass, that seems to be the Java that is the great Java that is holding us up for the client-side thing. So anyway, this is a third-party view now of things. You wouldn't be able to necessarily tell from looking at this what the clients are hit, because this shows the destination servers that you were querying. There is kind of a RESTful API, which isn't, well, it's not linked to from anywhere. But you could actually look at this and see the clients that were actually used if you wanted to. At some point I need to link this up, but you can see the clients that were used in the analysis. This is what I'm showing you right here with this raw, is the same output that you would get out of the DNSViz probe tool. Okay, Java is still running along. Let me try one other thing here and see if this works, and then we'll call it good so you guys can get on to your break. So let's see. Okay, so that worked. So if you look here now, and you're looking inside the bubble that kind of comes up when you're looking at this, you can see the server that was hit was 8.8.8.8. Everything looks good in terms of the chain, so it returned everything it was supposed to. And one other thing that you'll note here, you may say, oh, well, now you're storing all this information in your server, and anyone could see this URL. And well, that's true. It's not the same as when you're using, so what I've done is made a unique URL here with this kind of unique prefix, and the idea is that you may not want people to see what you're, to see this. And you could share it with people, but it's not automatically known. You would have to know whatever this idea is that's being used here from recursive analysis. And so the idea is to give you some confidence in the fact that sending diagnostic queries to a server which might be within your corporate environment or your own personal whatever, but that you still could get that perspective without it being, without the URL being known to others. So, all right. You love me. Does anyone have any other comments or questions now that I've had this these extra couple minutes to demo this. Hope that was helpful anyway. I don't see too many eyes falling, so thank you for your attention to that. Roy is coming up. Oh, okay. That's right. Should I be holding up something like the remote?
Yeah. Oh, brilliant. Thank you.
All right, my pleasure. Thank you. Sure.
Okay, just a few quick announcements before we break. That's us pretty much back on schedule, so we'll resume from the break at 11 a.m. As per the timetable. A couple of lost and found things. Just about the break. There's been some trouble taken with the various snacks as far as dietary requirements are concerned, so if you have any, check with Dinesh as to which snacks are appropriate. A couple of lost and found things. Has anyone found a MacBook Pro power supply at all? Okay, we have one attendee who's lost one, so if you do find that, let us know. Also, the glasses that were handed in yesterday, nobody claimed them, so they're now at the hotel, lost and found. That's it until the end of the break at 11 a.m.